Good evening, students. Today we'll try to learn about the refraction of light. Okay, so that is from the class 10th physics. Now let us see what is refraction of light. Okay, refraction of light. We have already studied about the reflection of light. Now we will move on to the refraction of light. Let us see, let us try to understand what this concept is. Refraction of light. Refraction of light through a rectangular glass slab. Through a rectangular glass slab. Okay, now let us try to see what is this. Now first of all, try to make a rectangular glass slab. Okay, so this is a glass, this is air. Okay, now let us try to make one normal ray, and now see, when a light ray incident at O, okay, when a light ray incident at point O on the interface at the surface. So we'll see, when a light ray tries to enter So this is a rectangular glass slab. When we can see, when a light ray is incident at point O and tries to enter in another medium, what happens? It changes its path. Also, it changes its speed also. Okay, so that we can say that the speed of light changes when it enters in one medium to another medium. Here we have seen that when a light enters from air to glass, that is from the rarer medium to denser medium, it bends towards a normal, and when it strikes on this interfaces on the surface of O dash, that is, now it enters from glass to air, that is from the denser medium to rare medium, it bends away from the normal. So we can say EF, this EO is the incident ray. Okay, and OO dash is the refracted ray. Okay, refracted ray, and this one O dash H is the emergent ray. Emergent ray, as we can see, it appears to be parallel to the direction of the path of the incident ray. That is why we call this is the emergent ray. First thing. Second thing, it moves away from the normal. So this is how the refraction through a glass slab occurs, that when a light, so the two things are there. When the light enters from one medium to another, its path changes, also its speeds also changes. So it depends upon the medium, its speed depends upon the medium. We can say that the speed of the light depends. Okay, so this is the refraction of a light through a rectangular glass slab. Okay, I hope now it's clear. Now there's a basic difference between reflection and refraction, and this is the refraction. Clearly we can see that when a light ray incident on point O and it enters from air to glass medium, it bends towards the normal, we can see, and when it moves from enters into air medium, again from the glass it bends away from the normal. That is why this ray is called emergent ray, this ray is called incident ray, O and O dash is called refracted ray. And let us, we can compare also their angles. I1 is the incident angle, R1 is the refracted angle, and here I2 and R2 are the incident and the refracted angle. Okay, so they are different, as we can compare them, the extent to which the ray bends. So that is what it is in the refraction. So okay, so now we'll study about the laws of refraction. Next topic is laws of refraction. Okay, so the first law is, that is, all the rays, that is incident ray, refracted ray, and normal to the interface of two transparent media at the point of incidence, that is at point O, lie in the same plane, we can see here that this EO, incident ray, this refracted ray, and the normal all lie in the same plane to the interface of two transparent media, that is air and the glass. Air and the glass at a point of incidence lie in the same plane. Now the second law is, if I write mathematically, it will be like this: sin I upon sin R is equal to constant. That law is called Snell's law of refraction. That law is called Snell's law of refraction. Okay, here the ratio of sine of the angle of I, angle of incidence, to the sine of the angle of refraction is the ratio becomes constant, and that is called the Snell's law of refraction. Okay, so these are the two laws of refraction we have. Now the next thing is, this constant is called the refractive index of the second medium with respect to the first. So now we'll see and we'll study now what is refractive index is called. Okay, so now we'll study about the refractive index. Okay, now we know that constant term is referred to the refractive index. Now let us study how. Now the next topic we have, that is called refractive index. refractive index. Now, two things are important about the refractive index. That is, first one, it is related to the extent to which its refracted ray direction of refracted ray changes, and number two, it's also related with the speed of light in one medium to the another. Okay, so if I consider air, this is medium 1, this is medium 2. So now when I when I have decided to find out the refractive index of second medium with respect to 1, is to find, like, the formula will be, that is speed of light in medium 1, that is v1 upon speed of light in medium 2, so we can write here 1 is equal to v1 upon v2. If I consider the speed of light in medium 1 is v1 and the speed of light in medium 2 is v2, then we can write like this. Similarly, if I try to find the refractive index of first medium with respect to 2, it will be speed of light in medium 2 upon speed of light in medium 1. Okay, so now we'll consider the formula will be v2 upon v1. So that is how we can find the refractive index. One more thing is, if for example we are taking now the medium 1 is air, that is vacuum. Okay, so and the medium 2 maybe I am taking glass, so refractive index of a medium will be, that is the speed of light in vacuum upon speed of light in medium, then it will be c upon v. Okay, c is the speed of light in vacuum, that is in air, and the speed of light in medium will be v. So that refractive index is called absolute refractive index. Okay, so that is what is given in the about the refractive index. And let me tell you that the refractive index of different materials like solid, liquid and gas, all these different materials have the different refractive index value, which will be given in during the exams when the numerical is asked. Okay, so when you need to solve a numerical where we need to find the value of the refractive index. Okay, so for one medium, then another medium refractive index value will be given, so no need to cram this. Okay, so now we'll study about the lenses. We have studied reflection in mirror, convex and concave mirror, that is converging mirror and diverging mirror. Now we'll study about the refraction through lenses. Two lenses we have two types, that is concave lens and convex lens. Here convex lens is converging lens and concave lens is diverging lens. So let us study about this. Okay, so now we'll study about the spherical lenses, how refraction occur through a spherical lenses. Let us see. Now, well, there are two types of spherical lenses. One is convex lens, that is converging lens. Okay, and another is concave lens, that is diverging lens. So let us see how they look like. So it will be look like this. Okay, so so thin lenses you have to make it. Okay, so that is the optical center. This is the convex lens. Convex lens, that is converging lens. That is converging lens. Here we have focus. Okay, so this is the center of curvature. We have f2, twice of f2, that is C2, center of curvature. We have two center of curvature here. So now what will happen when these rays, if I try to draw these rays, so this is a converging lens, that is convex lens. Now we try to draw that is concave lens, that is concave lens. Optical center we have f1, twice of f1, f2, twice of f2, the curvature. So this lens is called concave lens. That lens is called concave lens, that is diverging lens. That is diverging lens. So we can draw like here. Okay, so this lens is the diverging lens, that is called concave lens. So we can see here we have two types of spherical lenses, that is the convex lens and the concave lens. So these two spherical lenses, and now let us see how they work on which principle. First one, if I try to draw this lens, okay, so it should be very thin. Okay, it should be very thin lens. Optical center. C2 here, C1 is. Okay, so we can see the first principle, when a ray we are drawing parallel to the principal axis, it will passes through the focus. The first principle. Okay, the second principle is, now the second principle will be, okay, first one, when it is parallel to the principal axis and it will passes through our principal axis of convex lens. So after refraction it will passes through the principal focus. Second one is when it passes through the focus of convex lens. So after refraction it emerges to be moved to parallel to the principal axis. Okay. Third principle is That is third principle. Now we are talking about that when it passes through the optical center, it emerges to move without any deviation. So it emerges to move, passes through the optical center without any deviation. So these three principles are there on which these two lenses work. Now let us see what this also. Oh no, so we can't draw from here. We need to draw it from the center. Okay, so this is optical center. F1 twice of F1 C1, that is F2, that is called F2, and that is 2F2. Okay, now the first principle is, that is when it is moving parallel to the principal axis, to the principal axis, okay, it will be diverge from the focus after refraction to the lens. Okay, that is the first principle on which this concave lens work. Now the second one will be how we can show which principle it works like. First of all, draw a line, then try to draw the lens. It should be thin. Then we have twice of F2, F, okay, this is F1. Okay, so center of curvature 1, then we have focus 2, then we have C2. Okay, so now we'll try to see how and which principle it works. That is when it passes through the, when it passes through the focus. Okay, when it passes through the focus, it will be diverge, it will be so diverge from this. So here we can see that when it will be like this, so not from here, we will show from here. Now second one is when it diverges from the focus. Okay, so it will move this. This is okay. So the next principle is, now the third principle on which this lens we will show like this. Like this, we need to draw it properly for this. Okay. Okay, and that is optical center. That it, when it passes to the optical center, it emerges without any deviation. So this is the third point, third principle. So on these three principles, these two spherical lenses works. Now we'll draw the lens diagram and we'll see how the converging lens we have, when the object will be at infinity, so where the image will form in both the lenses. We'll see how the how when we'll change the position of the object, so how it will impact the position of the image. Okay, so let us see. Now we'll try to make the ray diagrams. Okay, now first of all, we'll start with the convex lens, that is the converging lens. So now I am taking out convex lens. Okay. Now the first case we have, that is when the object is at infinity. Okay. So when object is at infinity, is at infinity, okay, then image will form at f2. First of all, it will formed at focus f2. Second thing, it will be highly diminished. Highly diminished, okay, point size. Highly diminution points. Third one, nature of the image will be real and inverted. Real and okay. Now the second case we have, second case will be when object is beyond twice of f1, that is beyond c1. So where will be the image formed, or at its, where will be its position, what about its size, and what about its nature? Let us draw. Okay, that's the optical center we have. So now so we can say here it will form. Okay, so we can say it will be, if I say second thing, it will form beyond twice f2. Okay, one more thing is it will be diminished, okay, and real and inverted. Okay, real and inverted. Okay, so it will be like this. Now the third case will be when object is at twice of f1. Oh, okay. So we can see when an object, okay, So we can see here also, when object is at f1 to f1, that is c1, then the image will be at 2f2. Next size will be same size as of the object, and the third will be real and inverted. Real and inverted we have. Now the next thing will be fourth option. That is, what will be the fourth option we have? When the object when the object is between twice of f1 and f1. Oh, f1 twice of f1. Now we have at f2. Now when the image is between this, so okay, so it will be like this. So we can say when the object is between 2f1 and f1, image will form beyond 2f2. Okay, so we can say it will be highly enlarged. Highly enlarged. Second thing, real and inverted. Real and inverted, and will form beyond 2f2. So you can see we have tried. So we have tried 4 cases. Now the object will be at infinity, object is beyond 2f1, the object is at 2f1, and the object is between 2f1 and f1. Okay, now we'll go for fifth case. Okay, the fifth case will be when object is at f1. So what will happen? Object is at f1. So we can see when the object is at f1. Okay, so what we will see, image will be highly enlarged, real and inverted, and image will form at infinity. At infinity. Okay, so we have discussed now 5 cases. Now we'll move to the next one, and the object is between f1 and optical center. When object is between f1 and optical center. Oh, Okay, so we can see here that image will form beyond 2f1. So we can say first thing, image will be virtual and erect. Image will be virtual and erect. Second thing, highly enlarged. And third one, it will be that 2f1. Okay, so these are the 6 cases just we have studied now, how the convex lens refraction will occur when we'll see when the object is at infinity, object is beyond 2f1, so where the image will form. So examiner will ask in the exam like such type of question. Okay, so he will ask about that when the object is at infinity or somewhere else, where will the image form, of which size, and what will be its nature. So just now we have learned the spherical convex lens ray diagram. Now we'll move to the concave lens. Okay, so